All right, class, this is our last section of Unit 7, Section 6, Choosing a Factoring Method. Okay, so we're going to throw everything together that we've learned this chapter and factor these out. First, we're going to start off with telling whether each expression is completely factored, and if it's not, we're going to go ahead and factor it. Okay, so we've got a polynomial here, so we have a term and a binomial. Okay, so what we need to do is we need to look at the binomial. Is the binomial in simplest form? Is it factored out? So let's see. What are the factors for 6x? And then what are your factors for 4? It is not, because what we have here is we have a common factor of 2. So let's not forget our 3x squared. Let's pull out that 2, and then what do we have left? We have 3x. Now this is our binomial, so go right here to get your computation, and 2. So in simplest form here, we have 6x squared, 3x minus 2. Okay? The only factors that are in common with 3x and 2 are 1, so therefore it's in its complete factor form. All right, let's look at 2 right here. We have 5x squared and x minus 1. So let's look at this binomial. Is there anything common with x and 1 besides 1? And there's not. So this one is factored already. Nothing you can do with it. Okay, we have 2 binomials, so we need to break down each one. Do we have any common factors with x squared and 1? Besides 1? No. Do we have any common factors between x and 5? Besides 1? No. So this one is already factored completely. Okay? Now, let's look at number 4. We have 2 binomials, so we need to separate each binomial. Let's start with this one. We have 4x, which is 2 times 2 and x, and we have 4, 2 times 2. So what do they have in common? They have 2 2's. So let's pull out that 4. What's left is x plus, remember when there's nothing left, you can't put a 0. It'll change the value of that polynomial. You got to put a 1. And then let's bring down our second binomial there. All right, can we factor these out any farther? No. So that's our answer. Or if you wanted, you could write it this. Well, no, we need to be factored all the way, so that's our answer. Okay, something that will help you when it doesn't tell you which way to factor. These are the steps you want to try to do. First, you want to check for the greatest common factor. If there's a greatest common factor, factor that out first, okay? Second, you want to check for perfect squares. And difference of squares. And that's what you learned in 7-5. All right? Then you want to factor out with this. And we call that the T-chart. And then you want to finish with grouping, which is when you have 4 terms. Okay? So this is what you want to try to think in your head when you're factoring these out. All right, so let's look at number 5 here. Do we have a greatest common factor? Well, they all end in an even number, so I know that there's a 2, but let's make sure that it's only 2, all right? So let's factor out the 10x squared, the 48x, which is 8 times 6, 8 and 6, and then the 32, which is 8 times 4. Okay, so what do they have in common? And they do. They only have 1, 2 in common. Okay, so I'm going to pull out that 2, and what do I have left for this trinomial? I have 5x squared plus 24x plus 16. Okay, now we got to look at this trinomial and see if we can factor it more. So, do we have perfect squares? No, 5 is not a perfect square. So we need to look at this. This is our t-chart. So let's go ahead and do our t-chart. So when we multiply 5 times 16, we get 80, but when we add, we need 24. Okay, so 4 times 20 will give me 80. 4 plus 20 will give me 24. So let's factor this out. Now we need to keep this 2 here. All right, we're going to keep the 5 and the x, 5 and the x. Okay, so I have a plus 4 and I have a plus 20. Now what we need to do is we need to simplify. Any like terms here? No. Any like terms here? Yes. 5. So I need to divide each one of these terms by 5. So my final answer is going to be 2, 5x plus 4. 5x divided by 5 is x. 20 divided by 5 is 4. Okay? So I use greatest common factor here. And then I use my t-chart. And then I had to simplify that binomial. Okay, we good? I'm going to need to erase this so we can work number 6 here. Okay, number 6. We have a binomial, and let's see, we need to pull out greatest common factor. So I have 8x to the 6 y squared. So 8 is 2 times 2 times 2, x and y. Make sure you can see all that. And you can, okay? And then for 18, x squared, y squared, I have 9 times 2, x and y. Okay, so what are we going to pull out? We're going to pull out 1, 2, and 2 x's, and 2 y's. Okay, so what's left for my binomial here? I have 4x cubed minus something's wrong here. 1, 2, 3, 4, 5. I need another x there. So this needs to be 4x to the 4th. And guys, here's how I knew I made that error. I immediately, when I'm doing this, I'm immediately checking, okay? 2 times 4 gives me 8. X squared times x to the 4th will give me x to the 6th. I had a 3 there, and 2 plus 3 is 5, not 6. I forgot to put 1, 2, 3, 4, 5, 6 x's here, okay? All right, and then for y cancels out on that first one. Okay, so bring down your subtraction. What I've left for my second one, I have 9. So let's check. 18, check. X squared, check. Y squared. Okay. So we did greatest common factor. Now, do we have a perfect square here? That's the second thing to check. So, you can pull out a 2 and an x squared, and you can pull out a 3. We do, okay? Well, this is a negative, and it's a binomial, so it's a difference of squares. So what we have here is 2x squared, y squared. The perfect square here, 2x squared. Perfect square of 9 is 3. And remember, when there are differences, you got to do it again, but you got to add the 3 that time. And this is our final answer. So we did greatest common factor, and we did difference of squares on this one. Okay, I'm going to stop to make sure we have time and start a second part.